What we are going to do is we are actually going to get the size of the tree, which is simple. So we'll basically just get the basic functionality of the tree. So one is the getting the size of it, and then we'll actually print it in order, and then we'll actually print we'll do the print in order, print post order, and then we'll also do print a reverse in order. So let's actually go ahead and start with that. So we'll go to the BST, and then over here what we'll do is we'll write a function for public integer size. Okay, so we are getting the size. So we'll actually have return size of root. Okay, so we'll create another function, private integer size, which actually takes a node. Okay, so over here, first thing we'll check if node is equal to null. In that case, let's say if the root was null, if the node is null, we return 0. Okay. Otherwise, what we do is we return 1 plus get the size of its left, and plus get the size of its right. Okay, so node dot right. Okay, so this should give us the size of the BST, which is pretty simple. This is same as the binary tree also. So we'll just do and we'll do BST dot size. Okay, so we will actually do that. We can actually in the BST, whenever we do an insert, at that point of time we can actually have a local variable and then keep updating the values of the size. Also, that will actually help us later on, but like for now I think this is okay. So if we do this and we run this, it should print us the size of the tree, which is 9. And if we look over here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are correctly getting the size of the tree which is out there. Okay, so we are getting the size of the tree. Let's actually do a reverse level order. Let's actually print out. So that works good. So we did the pre-order. Let's do the in order. So we'll say BST dot in order. So we're doing the in order. We just run this, and when we run this, we should see 1, 3, 4, 6, 7, 8, 10, 13, and 14. This is very interesting in the in order, because if we do an in order traversal of a binary search tree, we can see that the output is always sorted in increasing order. Okay, so that is an interesting property that we can use. Where is the in order? Actually, let's do a reverse in order so we can actually get the opposite way. So let's do this. And so this was in order, and we'll say reverse in order. Reverse in order. Oh, I think I did some copy and paste error. I think I should have done it over here. So I'll do reverse in order and reverse in order, and this is reverse in order, this is reverse in order, and this is reverse in order. Okay, so instead of going to the left, we'll actually go to the right, and we'll go to the left. Okay, so I think this should be fine. So let's go to the main over here, and we'll say reverse in order, and let's print this out. So we can see that the in order actually prints it in increasing order, the reverse in order actually gets it in a decreasing order. That is wonderful. Let's actually add two more things. One is find the smallest one, and one is finding the biggest one. Post order, POST, post order. It should not be port order. And post order, and post order, and post order. Okay, so that is good. Let's actually find the smallest element. So smallest element will always be, if you keep going to the left, it'll be the smallest one. So we'll say public integer get smallest, and we will return, or we'll say integer. We will return get smallest with root. And what we'll do is we'll actually say private integer get smallest and then node. Okay. If we are over here, we can actually check maybe yeah, we'll check over here. So we'll say if root is equal to null, in that case we will return integer dot min value, dot max value. Right, so we'll actually say if you want the smallest one, I mean, like, we don't have anything, so we'll just return the int dot max value. Otherwise, what we'll do is we'll come over here and we'll say we'll check if node dot left is equal to null. In that case, return we'll say node dot data. Okay, otherwise we will return get smallest for node dot left. Okay, so that is, I think that should actually return us the value. So let's actually go to the main and we'll say PST, we want to get the smallest value. Okay, so run, and the smallest value is 1. Similarly, if we want to actually get the biggest value, we'll just copy this and get largest. And in this case, this will be right, and this will be right. And get the largest. If root is equal to null, we actually will return dot min value. Otherwise, we get the largest. If right is null, yeah, I think this should work. Okay, so that will basically get us the largest, smallest, and it will get us the size of the tree also. Okay, so we'll come back for other like functions.